lab number 12. The title for this lab is Ohm's Law. So we are going to explore Ohm's Law. As usual, I'm going to share my screen so we can take a look together. Okay, so that's your lab here. It's Ohm's Law. First of all, the lab introduces you to issues of voltage, current, and resistance. So the voltage source, like a battery, provides what we call current in a closed loop like this one. This thing you see here is the ammeter. It's used to measure the current and is connected like this in series. The box you see here is a resistor. It resists the flow of current or charges. An example of a resistor is a tungsten bulb. Inside there is a wire, and that wire actually is a resistor. So that's a resistor here, and here is the power supply, and that symbol is the shorter line and the longer one. It shows that current is moving from the longer line to the shorter one, so from positive to negative. So this is what we call a complete circuit. You can have this do this at in your house. If you have a battery, 1.5 volts, a small wire, you can actually, and a small bulb, you can actually make your own simple circuit, and you see that charges will be able to flow here, and you can see that using a bulb. So let me show you using a simulation. So I'm going to share with you a simulation. Circuit construction, PHET, University of Colorado, circuit construction. Okay. So that's the, okay, let me share my screen, but right now I'm not sharing. Okay, so here is the circuit construction kit. Once you click this, you can click on intro to learn a few things. That's the introduction. And let's see, the other one was what? We go back. We have intro and this one, the lab. Okay, pretty much the same. They're the same. Okay. You can click intro or you can click on circuit construction. So let's construct a simple circuit. I need a bulb, pull out the bulb. I need a wire. Oh, I need a power supply, battery. So I'll get this battery. So in our circuit, it was like this. The longer line was the positive part. The positive part. This is the negative part. And there was an ammeter. Ammeter is the current here, current reader. I'm going to put it here. That's my ammeter. Wire. There to there. Pick another wire. There. There. And then another wire from here. Another wire from there. Here. Then another wire from here to there. As long as we make it. So yeah, now we have light. Now we have light. In other words, this is our voltage source. This is our current. We call it current. It measures the rate of flow of charge. So current right now is 0.9 amps. This is the bulb. It is actually has some resistance, 10 ohms here. So the bulb is like a resistor. So coming to our simple circuit, this is what we have. So this is what is drawn in textbooks, and the reality kind of looks like this. Okay. Now A guy known as Ohms discovered that if whenever you increase the voltage, the battery voltage or the energy of the battery, more current flows in the circuit. So like right now, we have 9 volts. So we can increase the current. As I'm increasing the voltage, the current is also increasing. Now it's 47.5 and the current is 4.75 amps. If I reduce the voltage, the current also reduces. The brightness here is actually proportional to the current. You can see that as the current is increasing, the brightness is also increasing. So this is what we call Ohm's law. You can just investigate it here quickly, but we want to do some mathematics to understand Ohm's law. So Ohm's law says that voltage, Ohm's law just says that the energy supplied to the charge or voltage is proportional to the current in the circuit. The current. Now the symbol for voltage is V. So voltage symbol is V. Current, the symbol for current is capital I. And therefore, we can say that V is directly proportional to I, or some people write that V is proportional to I. Then, if that is the case, then you can write V is equal to Ri, where I is constant. So here, R is the constant of proportionality. And the R is a constant of proportionality, a constant. And therefore, from that formula, we can say that V equal to Ri, or you can say resistance given by voltage of current. If you plot a graph of voltage on the y-axis and current on the x-axis, like voltage here in volts, then the graph should be a straight line like that. And the slope of the graph go to resistance, because it's voltage, change in voltage over change in current. So the slope is actually equal to the resistance. So if you have a slope here, this would be rise, this would be your run, and the rise is actually delta V. Let me just do this a little bit more carefully. So we are saying that if you plot a graph of current in amps, remember the units for current is amps. I don't know if I mentioned that. V in volts, the graph line looks straight, and the slope, which is rise over run, rise. After rise here is change in voltage, and the run here is a change in current. And remember, slope is rise over run. So slope is equal to rise over run. That will be change in voltage over change in current. That one gives you the resistance. Therefore, a graph of voltage against current gives us a slope which is equal to the resistance of the wire. All right, so let's go back to our notes. Okay, so we understand how this works. More the voltage, the more the current, more the brightness. And we understand Ohm's law, the graphs associated. Now, how do we measure voltage and current? If we go back to our simulation, we will see that to measure the current, the ammeter, which is the instrument used to detect the current, has to be in series with the wires of the power supply. In series means in sequence like that. But if I want to see how much voltage is here, then I take a voltmeter. So a voltmeter is used to measure the voltage. So I bring it here, connect positive part, and connect the negative part there. So right now it tells me it's minus 6 volts. So that means I can switch the wires. So take this one here, this one there, and we get 6 volts. Okay, so we can, yeah. So let's put here, connect there, connect right there. Oh, we can see the meter here. 6 volts. So if it's negative, just interchange the wires. Then you get the right positive number, 6 volts. Or we can click on it and see what we have. Yeah, we have 6 volts here. And our voltmeter also tells us we have 6 volts here. So a voltmeter is connected across the power supply. An ammeter is connected in sequence or in series with the devices in the circuit in series. So that's what we are saying right here. We go back to our notes. So this is how to connect it. Schematic diagram shows you how to connect a voltmeter, how to connect an ammeter. All right, so we move on and say part 1. Part 1, we just want to simply investigate the connection between voltage and current. So it's a simple circuit. It's called a simple circuit, series circuit, with only one resistor. So they say connect your circuit. You set R equal to 100 ohms. So you go here. Instead of the bulb, we put the resistance. So you can pick this resistor. Let's see how much it is. 10 ohms. 120. So this goes to 120. So I'll put it like 100 there. Well, let's try to put it at 100. 100 has to be, yeah, there. It goes in steps of 0.5. So I'm going to pick it up and put it right there. So your resistor here is 100. Make sure I make a good connection. We don't need the voltmeter for now, so we can drag it back. Let's see, what else should we do? They say add a little internal resistance to the battery. You know, in real circuit, there is a little bit of resistance. So we need to add a little bit of resistance to the battery. So that's, we are trying to resemble or mimic reality. So we are going to say, okay, that's the battery. Let's add a little bit here. Some little resistance, like 4 ohms here. Because typically the battery has also some resistance. It's called internal resistance. Okay, good. What else? What does it say? They say using the following table, keep changing the voltage and record corresponding current values. So we are going to keep changing the voltage according to this table here. This table. So 3.5, and then not current, 4.5 current, all the way. So I'm going to show you quickly here. I click on here. I start from nothing. 1, 2, 3. 3.5 is here. Then the current is 0.03. Then click here. Increase the voltage to whatever. Take note of the current. So it will be voltage, current, voltage, current, voltage, current, voltage, current, until you finish the table, which is available right. Let's make sure we are recording this. We might be wasting our time. Just making sure. Okay, let me stop share just to check. Oh yeah, we are recording. Okay, so Okay, so in that part, you're done. It's just voltage and current. Then to find the resistance, you're going to divide voltage over current. Remember, we shared this formula before. So you have voltage over current, voltage over current. So this number divided by that, this 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 by that. That's your resistance. Percentage difference. Well, you are going to compare whatever you get here with here. So compare, let me write here. Students usually have problems here. Compare 100 ohms. Oh, by the way, this symbol stands for ohms from the guy who discovered the law. So 100 ohms, compare that with the calculated value. Okay, so you're going to compare that. Remember, there's a formula. Check out for the formula. Check out for the formula of percentage error. Percentage error. You can review. Go back to lab number 2. There's a formula that. So it's just 100 minus whatever you get here divided by 100 times 100%. So first of all, 100 minus whatever you get here, whatever you get divided by 100, that's known value, then times 100. Then you are percentage divided. Moving down, we are going to do the series circuit. A series circuit is just like the same circuit here. You can also add more resistors. So we have a series circuit here with 1, 2, 3 resistors and the power supply. So that's a series circuit. You're going to do the same thing you did in part number 1, but now with 3 resistors. So let's see the instructions. It says set each of the resistance boxes to provide from 80, 90, 100. So we're gonna do this. Gonna go to here. I don't want 1. I need 3 of them. So let's have 3. I'll break there and then put 1 resistor there. There. I'll break there, put 1 resistor there. I mean, maybe we have to put a wire in between. So need a wire in between just to reserve our circuit. Wire. Resistor. 1, 2, 3. Then connect to wire. I'm trying to mimic the circuit there. Okay. Actually, our circuit is like this. It's similar, it's not serious, but just want to draw it the way it appears there. Like that. There is sorry. Just trying to mimic that one. Right, there is a resistor here. Another one is right here. Another one, just take this one. Another one is right here, like this, according to the circuit. You can put as long as they are in series, they are in sequence, but I just want to make sure there's no confusion. So the battery here, and then they have wires. The wire, I can actually do this, doesn't matter. It doesn't matter, I can do that. Don't need a corner. There's a real kind of real circuit. So that's fine. You can put another wire here. So that's a series circuit. It's like a loop. I'm trying to actually mimic this circuit right here. You don't have to have the corners here. Doesn't matter. Oh, there is also ammeter. So let's put an ammeter there. Current reader. So somewhere here, we're going to break the circuit and put our ammeter. Again, it doesn't have to look like exactly like this. This is just a schematic diagram that you find it. But if you are on your table and you are constructing the circuit, it's just a loop, one loop. So the current has only one path to flow. That's a series circuit. Then start doing the same thing. You're going to start increasing the voltage and then taking down out of the current. So increase the voltage, take down of this. So increase the voltage, tell us the current. See, you're going to see the charges flowing. So keep on increasing the voltage, then current. But now we have 3 resistors. Go back to our lab 12. Am I working on the right document? Because I must make sure that I'm working with the right document. So what I corrected, I think, yeah, okay, this one. All right, so that's part 2. You're going to do the same thing. But now, here, what is the known value? Since you had 80, so let's copy this one. We're going to copy this. Copy that and put it down here. For percentage difference, what we do. So now you don't compare 100. You compare all the resistors. There is 80, 90, 100. Add them together. That would be 180 plus what's that? That's 100 plus 90, 190. We add it. That's 270. So 270. That's our total resistance. So compare 270 with the one calculated. So calculated value will be here. Okay. What do you do? Remember, when you do this series circuit here, remember you need to set the resistors accordingly. This has to be 80, this 90, this is about 90, and another one has to be 100. So set it to 100. Okay, set this one to 100. Right, remember to do that. Then we move on. That's a series circuit. So if you break the circuit anywhere here, you lose all the current. That's how a series circuit works. You cannot use this for Christmas lights, because once you break a circuit here, you lose all the lights. And we need to look at another circuit that is appropriate for this. So the other circuit is called a parallel circuit. This one has so many branches for current to flow. When current travels from the power supply, it branches into different resistors. The resistor that has more value will have small current. If the resistor has a small value, then more current goes there. So current will go to the most of the current will go to the smallest resistor. But you don't have to worry about that. You just have to look at the experiment. So in the experiment, we are going to connect the circuit as follows for the third part. Connect the circuit as follows. So this one, I'm going to give you a challenge to that. But maybe you can do this, just connect it like that. Let me do it. I don't know. I think you might have some problems in there. So I'm going to do this one. Okay, just go back. Okay. Reset. Actually, there should be a reset button somewhere down. If you, there should be a risk here. So if you want to go back, you can click the reset button. So for a parallel circuit, you take a resistor, put it there. Another resistor is here. Another one is here. Then take the wires, connect the wire from there, here. Connect another wire from there, there. Connect another wire from there to there. We have so many branches. So the current has multiple paths to follow. Then the battery is here, but I need to put an ammeter so I can check a reading. So the battery is like that. Doesn't matter here because any branch has the same current from the power supply, either left or right. Anyway, we have the current there, and then we have a wire here to there. Now we have our parallel circuit. Set this one to 80, set this one to 90, set this one to 100. Then take readings again. So you are going to keep increasing the voltage and taking note of the current. So in that case, you are good. You are actually doing the parallel circuit. You do the same thing. This is the table. Change voltage, observe the current, calculate the resistance, V over I. Now percentage difference. So I copy that one. Percentage difference. Okay. Here, the percentage difference should be comparing 1 and 5. So let's put percentage difference here. Okay. All right, here. Now you are not going to use 270 because theory tells us that when resistors are connected in parallel, the formula is different. So when they were in series, we just added them up. But resistors in parallel, when you have your power supply here, my power supply battery, and I have my ammeter here measuring the current, and I have resistors, another resistor here, another resistor here. Let me just draw it nicely. Okay, this one. Okay, so maybe this is 1, this is 2, this one is 3 up there. 3. So resistor 3 is up there. I don't know how to draw it. Okay, let's just do this. Yeah. So this will be 2, this will be 1, and this will be 3. And your current reading somewhere there. So if you want to find a single resistor that represents 1, 2, 3, that means you are aiming for from the power supply to the battery. You are aiming for one resistor, which we call equivalent resistance, REQ. To find that one, you don't just add R1, R2, R3. For a parallel circuit, you use this formula. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Then you plug in the formulas. So 1 over R equivalent. What was that? I think it was 80 plus 1 over 90 plus 1 over 100. From here, you can do your calculations and find what is REQ using your calculator, or you can use a calculator online. Let me show you. We can find actually equivalent resistance using an online calculator. So go to Google. I'll go to Google and see what am I looking for. Equivalent resistance. Equivalent resistance in parallel. Let me see what it shows up. I'll show you. There's so many formulae online. Just plug in. What is the calculator? Oh, there's no calculator here. I need calculator. Series and parallel circuits. So it's equivalent in parallel calculator. So we're looking for calculator. Oh, here. Okay, so there's so many websites, a lot of them. Then just go to the circuit you want. Okay, so I'll share with you what I'm seeing here. Share. Okay, I'm sure you're able to see my circuit. Then we're going to say number of resistors, 3. 3. Then you add them here. 20B3. So you add the 80, then you add the 90. We're supposed to have 3 resistors, right? Why do they have only 2? Not a good calculator, because I need number of resistors 3. Oh yeah. So when you click 3, enter. So it gives you that option. So we had 80, 90, 100. Then you calculate. You press calculate, then the answer will be down there. So the equivalent resistance is 29.75. You can go ahead and do the calculations, but also compare with this. So this is 29.75 according to this calculator. If they were in series, you wouldn't use this formula. Just add them up. Go back to our lab 12. So now we compare with what? 29.75 ohms to the calculated value. Check out formula for precision error. All right. So basically, we are just exploring Ohm's law, which says that voltage is directly proportional to current, or voltage equal to R, or the total resistance R times I. The total resistance for the basic circuit is just 1. In the first circuit, you only have 1 resistor here. In the second circuit, second part, you have 3 resistors. So Ohm's law says that voltage is proportional to the total resistance here times current. In the third part, Ohm's law also says the same thing. Voltage here, V, voltage V here is proportional to current. But then the total resistance here has to be found using this formula. So exploring Ohm's law using different types of circuits. Then you come here and answer these questions. So very interesting questions. After you finish, this is just objectives here. For the same amount of voltage, when do we have more current flowing to the voltage source? When resistors are connected in series or when they are connected in parallel? I want you to think about this. When do we have more current flowing? You might want to do a check by trying to replace this with a bulb. So you can do this. Let's have this one here. And I'm going to put a bulb right here. Bulb here. Remove this, put a bulb. Move this, put a bulb. I want you to try this one out. I put a bulb here. I put another bulb right here. Okay, then put the wires. One wire connects to there. So we just want to see what happens when we have okay, so so there's a disconnection somewhere there. Okay, so this look. Okay, this connects right there. No, it will be on this. All right, then take the wire from there to there, maybe it's one. And there's also a connection right here. It's expanded. Okay, wire. I'm making a parallel circuit, but then what I want a lot of brightness. So let's use the voltage. Okay. They're bright. Looks like one of them is connected to this one. We need to fix this part. Sorry. Okay. Don't know what happened there. So we get out how to go back. Okay, so timed out. let's see. So the idea is you're going to connect the two circuits. I will still want to show you that. So let me see why I have been kicked out. I don't know. PHET Simulation. You guys can try it out. It's very interesting. So see which one you have more brightness. It will be very interesting. So I don't want to spend too much time now, but I want you to give it a try. I want you to try that one out and see what you get. So you are going to answer this question based on your understanding of the circuits, based on your data, or try the circuits. You have to have two circuits, one series, another one parallel, and keep the voltage the same. And then you use the what? The bulbs to see the brightness. So, or to check the current. And then you are going to get your answer. Now, let's say you want to connect Christmas lights in such a way that if one light breaks, the others will still can work. Should you connect lights in series or parallel? This one you have to make sense of all the parts of the lab. What contributed to the source of error? You have a percentage difference somewhere, and you must think about what contributed to the source of error. All right, guys, let's stop here. I wish you all the best. We have two more labs after this, yeah. So almost there. Thank you.